good morning to all of you. So in the last lecture, we have studied about the astable multivibrator. So today we'll try to understand the mathematical analysis of the astable multivibrator. So basically, as you know that the IC 555 is made up of three resistances, that is 5K, 5K, and 5K. So what we'll take VCC as 15 volt. We take VCC as 15 volt. So when you are having, I'll have to change the color. Just a minute. So when you are taking VCC as 15 volt, then what is going to happen? You will be having 5 volt at this point, then the 10 volt at this point. So basically it is a voltage divider circuitry, and this 15 volt will be divided across three resistances. Fine. Now this 5 volt will be given to the first input, that is the inverting input, non-inverting input of the comparator 2, and 10 volt will be given to the inverting input of the comparator 1. So the output of the comparator depends upon the next input which we are applying, and the same input, that is the voltage across capacitor, will be given to these two inputs. So you have got the discharging path also, and this transistor operation depends upon the flip-flop operation, and in the flip-flop operation you will be having only two states, two important state we can say, when S and R. So when S will be equal to 0, R will be equal to 0, so the output will be the initial value, initial state, whatever we have done before, whether the transistor will be on or the off. When you will be having 0 and 1, it means set will be equal to 0 and reset will be equals to 1. So will be equals to 0. Output will be reset. Now similarly, when S will be equals to 1 and R will be equals to 0, so output will be set. And this is this condition is not there, so the output will be in the indeterminate stage. So we are going to use only these two important states. So now you can see that the capacitor will be charging by using this supply voltage, and it will get discharged through this transistor. So when it is charging, that time RA and RB will be in series, and when it is discharging, it will discharge only through RB, because we have connected the discharge transistor, or you can say the collector point of the transistor, to the middle point of the resistor. Fine. So the discharging time constant will be RB into C. Suppose if you want to write the discharging time constant, then what will be the discharging time constant? That will be RB into C. The time required for the capacitor to discharge is called discharging time constant. Now similarly, when it is charging, so it is going to charge through a supply voltage, and the current will flow through the resistance RA, then the resistance RB and C. So in that case, it will be RA plus RB into C. So this is one will be the charging time constant. So based on these parameter, we'll be able to find the time the time of required for one cycle, and accordingly the frequency of the square waveform, whatever you can call it as. You can call it as the square waveform or a triangle waveform. Now, initially the capacitor is at 0 volt. So when the capacitor is at 0 volt, so what is going to happen? This one will be a 0. The capacitor is uncharged. So 0 and 0. So you can see that this one will be 0 and this one will be 1. So it will be reset. So I think this path is broken. This path is broken. There is no there is no connection between the transistor and this path is broken. Why? Because the 0 will be at the base of a transistor, and the transistor will be operating only in two states. The first one will be saturation, and second one will be the cutoff. So cutoff means what? That the emitter base and the collector base junction will be in the reverse biased. That time it will be in the cutoff state, and when both are forward biased, it will be acting as a closed switch. Fine. So basically it means that there is no discharge path. The capacitor is going to charge, and when it is charged, so it is charged through the supply voltage. So the capacitor will be storing the charge, and eventually it is developing a voltage. So what is going to happen? the capacitor will be voltage. So I think the voltage is going to start from okay 0, then it will reach to 1, then 5. Suppose I think there are two limits. We can write here there are two limits. There are two limits, that is 5 and 10. 5 and 10, there are two limit, 5 and 5, and this one is 10. Just a minute, this one is 10. So the capacitor voltage is charging from 0. So what is going to happen when the capacitor voltage crosses 5 volt, and suppose if it is at 6 volt. So now we'll change this as 6 volt. Just a minute, hold on. This is 6 volt. So what is going to happen? So this one is 6 volt, this one is also a 6 volt. So now both the comparators will be low only, and you will be having a 0. It means that the initial state will be retained and initial state will be followed. So in that case, your this path will remain open only, and the capacitor will continue to charge. So now it will charge till 10, then the 11. Suppose if it crosses 10, and then you will be having this 11. So 11 will be there. So this one will be 11, this is also 11. So what is going to happen? This one will be 1. So when S will be equals to 1, Q will be equals to 1, that is the output of the flip-flop is set, and this voltage will be given to the transistor. So basically what is going to happen, this will be acting as a short circuit, and when it is acting as a short circuit, so capacitor has got the path now. So capacitor has got the path now, and in that case this will be acting as a short circuit. Fine. So the capacitor will discharge through this path, and now it will not discharge instantaneously, it will discharge exponentially. Why? Because the time constant is there. Suppose if resistor value is absent, then it will charge like this, it will charge instantaneously. But due to the resistor value, due to the introduction of the resistor value, it will take some time to charge. That is called the discharging time constant. So I think yesterday we have got this type of waveform which we have seen, and so I think this waveform is very much visible to you. So when the capacitor voltage right, the capacitor voltage for the charging purpose. Now this is the capacitor for a charging. I think this formula is known to all of you. This is not a new formula which I am telling you. That VC will be, this is the voltage at any time t. So now you can see that your capacitor voltage is charging and discharging between the two levels. The first one will be 2 by 3 VCC, and second one will be 1 by 3 VCC. So it is, we can say that it is oscillating between the two levels. But the formula should be from t will be equal to 0 to t to some value. So it means that you will have to take two time. That is, first the capacitor will be charging from the capacitor will be charging from 0 to 2 by 3 VCC, because ultimately our limits are 1 by 3 VCC, or you can say 5 volt, and 2 by 3 VCC, that is a 10 volt. Fine. So you will be having two limits. So in that case, first you will have to evaluate the time taken when the capacitor voltage will charge from 0 to 2 by 3 VCC, and in next case is 1 by 3 VCC. Then you subtract these two times, then you'll get the capacitor charging from 1 by 3 VCC to 2 by 3 VCC. So I think we did the same thing. You can see here the 2 by 3 VCC will be VCC minus T1. So T1 will be 1.09 RC. This will be T2 will be equal to 0.405 RC. So the T high will be equals to what? 0. You just have to subtract these two times, because ultimately we want a charging time from 1 by 3 VCC to 2 by 3 VCC. Now similarly, when the output is low, so output will discharge from 2 by 3 VCC to 1 by 3 VCC. So the discharging time will be, I think the sign time will be, this is e to the power of minus t upon RC. So I think you are going to have the low value, that is t below will be equals to 0.69 RB RBC, fine. So, what is the total time period? In the total time period, you will have to consider the high pulse and the off pulse. So, T high will be you have calculated, then T low will be calculated. You just have to add these two value. So, I think after adding, you are going to get this 0.69 RA plus twice RB into C. I will change the color for the more clarity. Okay, so duty cycle again. Duty cycle means what? Means the time period for which your circuit is giving a duty to your load, or you can say to you. So in that case, you will have to consider only the high time upon the total time period. So what we have considered T high upon T, that will be duty cycle. And if you want to calculate the percent duty cycle, then you will have to multiply it by 100. So this will be the astable multivibrator mathematical analysis. So I think we'll stop here. We'll meet tomorrow.